Okay, so we are starting with the topic of understanding APIs. As I've said, whenever we work with products in the industry, most products today integrate with each other using APIs. And hence, if anyone has a good understanding of APIs and he's able to troubleshoot and integrate and implement APIs, it's a very, what do you say, in demand and I should say, a valuable skill in today's working environment. So what is an API? API or application programming interface is a software bridge that enables two applications to communicate with each other, right? So before APIs, what would used to happen? That is what we called a very hard integration, in which we would make connections and we would you know allow the other service to actually log into our system and then the make changes or read the information, right? So a simple use case can be, suppose if I have some information in my database and I want someone else to read that information. So in earlier cases, I would have created a user for that person who will log into my database using some MySQL client or SQL client, and then he will read that information. Now that means that one, that is a very tight integration, as we call it. We cannot change anything at our end, because immediately we change it in our backend, his queries will be impacted. Any kind of access problems are there, he is not able to do much about it. So when our backend systems are more exposed, our the changes to the backend systems becomes very complicated, and the people who are accessing it from outside, uh, first of all, there's a security risk, and second, they have to actually create the entire environment at their end also. Okay, so that was a difficult thing. So then came the APIs, in which we basically create web services, and we create kind of a layer between our application, uh, and this layer is kind of we can control the security in this layer, we can control the access controls in this layer, we can publish this layer anywhere, maybe on the cloud, so anyone can access it, and so many other things, right? So that made life of everyone easier, to the extent that today when we design applications, and if our applications are uh, composed of different components, then even internally even within the application also, these components talk to each other over APIs, right? So that we can maintain each component or module separately, which is also known as microservices, if you know. So modern APIs have evolved into developer-friendly tools with clear standards, typically following HTTP and REST protocols, making them easy to use, self-explanatory, and widely understood. Uh, so as I was saying that we even within the products today, the different components or modules or services within a software product also talk to each other over APIs. Similarly, now when we say that there is a terminology called API first product, right? So what it means is that while designing the products, developers will first design the API layers, and then they will start designing the backend layers. Uh, Now these API layers are actually also treated like a product itself, right? So they have their own life cycle. Okay, and the way we will go about planning the product, the planning the releases, planning the features, similarly we will be doing it for our APIs. Generally these API documents are available online, so you access any website. Say for example, if you go to Razorpay, or if you will go to Facebook or Meta, right? All these API documents are available. You can simply take those API documents, and using those APIs you can integrate with their software. These are very robust APIs, or the back end and the front end are both very robust. So you can be sure that if you are following those documents, you will be able to successfully do the integrations. Okay, so so some of the characteristics of the modern API, we have HTTP and REST standards, right? So these are API developer friendly and widely accessible, and obviously, as you have seen, these are product like design. And through documentation and versioning, we ensure clear expectations for updates and lifecycle management. Performance and scalability. So again, performance is a key factor. Today, when you are using these APIs to connect with everything around you, so the people when designing these API interfaces and the API servers will take care of the performance and stability. And yes, security and governance. So the security aspects are actually strictly built in. So you have authentication mechanism, you have authorization mechanisms, all which are very standardized. And we can always control whether what data we have to share and what not. As I've said that they go through with the proper they are treated like a product. And they follow software development life cycles. So whichever methods that company is using, either traditional waterfall method or agile method, uh, basically the software developers will take care of it. Okay. Now a common example of uh, an API which you can also use today, it's an open API, which is a weather app, right? So what, or weather API, it is there. So if you want to say design a mobile app in which people can see the weather information, you can simply start designing the mobile app, and there is a weather API available. It's an open API. You can access it over internet. You can refer to its document and basically do the necessary coding in your mobile app, so that whenever a user requests, this app will fetch the data from this API and show it. Okay. So no longer we have to be bothered about maintaining some server, etc., etc. Simply calling the API and our job is done, right? So this is the power of APIs. So how to use an API? So the first step is obviously starting with the documentation. So you have to find the documentation of the API. Generally, as I've told you, most of the websites which are having this APIs will have them in their documentation part. You can simply go there, access them, and download them, right? Uh, you should be aware about the URLs that we have to use and the protocols that those documents says. Third part will be for the security purpose. So these websites will allow you to log in and create your tokens or API keys, which actually identifies you to the API. Basically, when you send the request, so you will either send these keys or tokens along with the request, so that the app server at the other end can identify you. Okay, and obviously then you will use the JSON or XML to send the data or receive the data. So this is as simple as this. So what are the types of API? So there are open APIs, internal APIs, and partner APIs. Open APIs are publicly available APIs, as I have told you about weather API. Internal APIs, as I've said that within the product also, we now today the modules talk to each other using the internal APIs only. And then we have the partner APIs. So these APIs are designed for other users, right? So here you are saying to the market that please use my APIs and use it. So weather API is a kind of example of both open API and partner API. Okay, internal APIs are not exposed to public. They generally are within the what you say development team at the customer end, at our end. In terms of technology, today we are types of APIs are very popular. One is REST APIs. So this is widely used for building web services. It uses HTTP methods like get, post, put, delete to interact with data. Uh, and REST APIs typically return the data in a lightweight formats like a JSON or XML, making them easy to integrate. Also, if you know about them, then REST APIs generally will consume less bandwidth during the integration. Okay. SOAP APIs are a simple object access protocol. It is a messaging protocol that exchanges structured data between web services. So These are also a standard APIs, and they were very popular before REST APIs. But they typically use XML for data exchange and are generally more complex than REST. Okay. They support advanced features like security, transactions, reliability, but tend to require more bandwidth and processing power. We also have something called GraphQL APIs. It's a query language developed by Facebook. So generally, Facebook APIs are called Graph APIs. GraphQL allows developers to request only specific data they need in a single query. Okay, this amount reduces the amount of data transferred and improves the performance. Then we have webhooks. These are used for real-time data transfer between applications, right? So what happens is that when you know that there is an integration that has to be there and it has to be consistently there. Uh, so in case of API, what will happen is that whenever you need something, you will call the API and get what you want. Okay. In case of a webhook, it's kind of opposite, right? So in case of a webhook, what we are saying is that whenever something happens, say for example, we say that whenever the temperature in a certain city goes below 21 degree 0 degree Celsius, some alert should come to my app. Okay, in case of a weather app, right? So in that case, API won't work because the my application or my app doesn't know what has happened at the other end. So in that case, we create webhooks. Okay, this is again typically done using HTTP post. Webhook APIs are commonly used in event-driven systems such as notification or chatbots where instant updates are required. Yeah, so JSON format is nothing but this format. This is typically a key value format in which you are putting a key and the value after that. In case your key has got multiple options, then you further uh, divide them, put them into brackets and put them like this. Uh, and then finally, if you when you are having some arrays, this is how you will handle these things. So this is a typical format. There are many tools available to format your JSON in the JSON types. When you are doing programming, there are so there are many commands also available. So each language will have a, what do you say? I should say a library that will allow you to encode the data into a JSON format. Then we have this traditional XML version, which is very much like your HTML, where you are placing your entire structure into these tags elements, and you can just create the entire structure like this. One more way of seeing APIs is stateless versus stateful APIs, right? So stateless APIs treat each request as independent with no connection with the previous request, whereas a stateful API will keep track of the session and state information on the server for each client. Okay. So this means the server remembers the data from the previous request and uses it to handle the future request, right? So if you are having a stateful API, then it will need something like a session ID, tokens, cookies, so that the server can know that okay, Shutosh only requested some information before 5 minutes. Now he is just requesting it again, so maybe I have to do something different. So obviously there are logics also involved that why do you need stateful API? So a typical use case be online shopping. Okay, so when you go to a website and add your you know items in your cart, right? So when you will again access your site, you will know that those items are there in your cart. So your process flows and everything, the entire logic flow will be different. Okay, maybe you will get an alert that okay, items are in your cart, so please clear them or some purchase them, something like that. If you don't have anything something like that, you might not get such things, right? So there are so many things which change depending upon the last interaction that you had with that site. But in case of our weather API, weather app, nothing like that. We can simply uh, keep on requesting. So I can request the weather after 5 minutes, 10 minutes, 1 minute, whatever I want. So I don't need to maintain the state. Similarly, we can have synchronous and asynchronous APIs. Synchronous APIs expect immediate response. So synchronous means that when we send an API request, I will wait for the response, and only once I get the response, I will move further, right? So my entire uh, application will wait till I get the response. So an online payment gateway is a good example of synchronous APIs. So you would have seen that whenever you make online payments, your pages, like they say that don't refresh your page, and after some time that page automatically refreshes, and then it is redirected to the vendor or the trader from where you started the payment, right? So why this is required is because we have to wait for the payment confirmation, right? Otherwise, it can be a problem. Okay, whether payment happened or not happened. So what payment API are doing is they are actually ensuring that the payment has reached the destination, the pay bank account, and they have received the response, and then they confirm, so that tomorrow there cannot be any conflicts. Uh, Asynchronous APIs, again, they don't wait for anything. They are just more like alerts and messages that are going. Uh, Normally, whenever you're talking about asynchronous APIs, you are talking about a scenario where something is automatically getting triggered. Okay. So these APIs are useful when the response time is unpredictable and when the task requires background processing. Uh, but there's nothing dependent on these tasks. So for example, like the example we have given, so whenever you complete your email registration, for example, or a registration on a website, you will receive an email after some time saying that you are registered. Now, this email you can receive within a second, within a minute, or within 10 minutes, or maybe within a day also. Uh, Depending upon, so what this application would be doing is, once it accepts the registration, it would be feeding another system internally where it will be kind of creating a email a queue in which the name, the email ID, and the other details would be fed, and a separate email service would be sending these emails, right? Because these are not critical or crucial emails that uh, like change or impact someone's ability to work. These emails can be received in a bit delay also. So my system doesn't have to wait for that to happen, right? Um, Another key factor in API design is called API rate limiting. So, uh, so whenever you design an application, right? One, there are two things, right? One is, say, suppose someone wants to abuse your application, right? So we have already heard about flood ping attacks, right? So earlier, what people used to do with, they used to generate these automated pings to our machines so that our machines could not respond to these and would go down. Similarly, for APIs, people can do these things. People can create bots which keep on sending the API request, and it will overwhelm our entire API interface. So for that, what we do is, one that we can do is we put some rate limits. So if from a certain source, we can even have such logics that if from a certain source I am receiving, say, 10 requests per second, so you block that IP, right? So at the network level itself, it will block it. Those kind of things have happened. Other thing is that whenever you are designing APIs, and say even for third party or internally, you are exposing it for others. So your applications, every application that is out there in the market, it is designed for certain load, right? Uh, it is not infinite. So if what kind of server machine I have put, what kind of bandwidth I have, what kind of CPU I have, what kind of load balancing I have, what kind of uh, you know scale up mechanisms I have, all these things will depend upon it. So if I have designed an API that should, so my business is a small business, I expect only 100 requests to come in a second, right? So I will design that for 100 requests per second, or that is called transactions per second. Maybe if I am Hotstar and India versus Pakistan match is going, I would have designed my interfaces to handle 1 lakh requests per second. But then entire design changes, right? Even my applications, my infrastructure, my deployments, my support, everything will change. So if you don't, so there is a way that we can put these rate limiting controls on our APIs. and so that in case due to some mischievous activity or some error, at times we also encounter some errors like my application starts sending multiple requests without a trigger, right? So there's a bug in my application. So for that, um, we can put these rate limits.